This will be the proton. So what is the charge? Proton. Proton will have a charge of that one. And what should be the value of that? Z should be equal to 1. And here is what that particular μ-meson. So what is the mass of this? Charge will be electron. The mass of this, I think we took m1 no here. How much it is? 2 times of mass of electron. This is m2. It's a proton. Mass of proton given. It is how much? 1836 times of that one. So here m2 is 1836 times of mass of electron. M or me. Okay, now with this asking the radius of the first Bohr orbit and the binding energy of hydrogen. The radius of first Bohr orbit and the binding energy of hydrogen are respectively. Calculate the radius of the first Bohr orbit is asking. What is the 0.529 y as given? If it were electron were there, compared to that is asking us now. I think that is the formula, no? Just now we had a formula. Expression for Rn, A naught n square Z me by mu e. A naught n square Z by me by mu. How to calculate mu? 1 by mu, let's use this formula. Mu is equal to m1 m2 by m1 plus m2. m1 is 207 m by 207 me plus 1836 me. I'll get the mu in terms of me. So me by mu I'll substitute, and we know a naught. What is a naught? A naught is 0.529. So I'll get the radius of the nth Bohr orbit. Calculate the radius of the first Bohr orbit. So what I should substitute? N equal to 1. What about Z? What I should do with the Z? Should be equal to 1, no? Okay, I think able to manage. It's all about just the formula, no? Nothing big. No, energy in the, and it's telling us, and I think calculate the radius of the first word, the binding energy and the wavelength of the line in the Lyman series of such atom. Is asking next to calculate the binding energy. For that, what I should do? I should go for the energy. So what is the basic formula for energy? Energy should be equal to, and just now we derived it, no? This should be minus. Definitely you can feel these are, sir, is it formula if I remember enough? Yes, you can manage. Z equal to 1, mu value you know, n. So we'll get the required, the binding energy of this particular thing. Binding energy means what shall I do? What is the meaning of here? Binding energy is telling the energy with which what happened? The electron will be binded to this particular atom. So put n equal to 1. What you get energy, that is the binding energy. What you calculate, that will be the binding energy in electron volt. After this is asking the wavelength of the line in the proton, no? What is a proton? What is the charge of proton? Equal to plus C, no? So Z equal to 1. Okay. And then how to get that first line of Lyman series? Sc by lambda lambda 2 1. We say like this, no? This should be equal to initial E2 minus E1. How to calculate E2? Again, you have to put n equal to 2. So for n equal to 2, you calculate E2. So like this, you can draw again the spectrum little bit slightly different, like what we earlier discussed, the hydrogen atom with nucleus at rest. So now you can question that. So is it really proton moves? If it were electron, then we would have neglected the moment of photon, the displacement of photon. Since here, look at the revolving particle. There's a revolving particle. What is the mass of the 207 times mass of electron? So definitely it is having, the mass is not negligible compared to mass of proton. If it were only just ME, M1 equal to ME, then definitely ME will be very much less than 1836 ME. So then we say proton at rest and the electron is revolving. Since the mass of revolving particle is 207 times the mass of electron, it's not negligible compared to nucleus. So therefore, we are bringing the reduced mass idea. Can you work out calculations? I'll proceed to the next part of the problem. I'll give the answers cross check. It will be. Radius R1, and this R1 is 0.002. There's a one answer. Cross check it. Then binding energy will be minus 2530. 0 electron volt. Then the wavelength is given by 653.6. Do calculation later on. This idea is what I'm sharing. Now you can ask question. Sir, what happens if the charge of electron, the charge of revolving particle is 3 times charge of electron? Where do you make changes? Can also be asked, no? So it's an electron. So I can bring some other charge particle, no? What is that μ-meson? It is having a charge that of electron mass 207 times. Okay, then what to do if this mass of charge of revolving particle is say some 2 times of electron or 3 times of electron? For atom to be like a neutral, what happen? The charge of what happen, the proton, what happen will become 3 protons will come. Then proportionally what you should write, Z equal to 3. Then carry on the problem. But no such thing. I'm just saying in exam hypothetical, they may make it and you can put that one. If the suppose say charge of revolving particle is 3 times of charge of electron, then similarly there should be 3 protons. Then Z equal to 3, you have to substitute, then you carry on the problem. Okay, hypothetical, they say hypothetical, but no such thing, they just say hypothetical. The same problem, this is like a μ-meson is bound state of negatively charged pion divided by pi. So here 273 ME and a proton, estimate the number of revolutions. I think the same thing, only the mass of revolving particle has become 273 ME. Earlier 207, now 273, like that the charged pion. I think in chemistry maybe it's useful. Physics just like a reduced mass, we have to take it. So work out such problems. I think it's there in Singage book. Some 3 numericals are there. In Icon also there are 2 are there. Work out few. Let's go to the next one. No, if it is there is an atom which is there in the